to the final review for Math Foundations of Math 108. Excuse me. Wait. Gosh, sorry. Um, this is it. This is your last thing you have to do for this class. So hope you do well on it. Let's just start. I'm just going through some of the highlights of the review that's in the Maple TA. So first thing we're going to do, let me show you my tools first. My first thing I have all of my formula sheets pulled up. I have mine in Adobe Acrobat, but you can also just pull them up all on a web page, but you just have them all together. So they're all right there, ready to go. I also have my key for the second financial template. What you'll need, yours wouldn't say key, it's just your second financial template, but these financial calculators are pretty helpful. So we'll be using those. And see, I just hid those. Let me put them back. And then of course a calculator. And I think that's it. So let's get started. The first thing we're going to do, if I can find my test now. I keep piling stuff on top of it. So I got my formula sheet, got my template. Here it is. Okay. Here's our practice final exam. First problem. If your GPA is 3.85 and my GPA is 3.37, then your GPA is what percent higher than mine? So this is something from our very first our first exam. This is what we're calling absolute and relative difference. So what they're saying is, what's the difference between your GPA and my GPA, or what's the difference between your GPA relative to my GPA, okay? So the answer for this is it's a relative difference. They're not asking exactly how much, because they're asking if it's higher. When you hear the or the ER, you're comparing it to something, okay? If you're not comparing it, they just want to know. The difference between those two scores. You would just subtract those. But because they want to know that it's a percent, if it's a percent higher or whatever, then it's going to be the relative difference. So what that is, you take the the absolute difference divided by the reference value, or so what we're going to do is we're going to subtract those. The absolute difference is subtracting. So I always forget that as soon as I start writing on that, that's going to disappear. You guys will not be able to see it. Well, I can see it, so sorry. All right, so how it goes, my GPA, we'll call it, this is my friend's. My friend's GPA is 3.85. My GPA is 3.37. And they want to know if it says higher than mine. So mine is going to be the reference point, okay? So we take the difference between those two, 3.85 minus 3.37. And that is going to be divided by the reference, which is 3.37. Now, if they asked what percent lower was mine to my friend's or to yours, then it would I would have a different reference. So you want to make sure you know what that reference value is. And then you just do a calculator. Where we go 3.85 minus 3.37. Make sure you push equals here so that you get the right thing, and then you divide it by 3.37. If you don't push equals, it will divide this by this. You just have 1. So my it's 0.142, which is 14.2%, and that's the correct answer on here. So that's how you do those. Again, that's something from way back at the beginning. It's hard sometimes to remember the things we learned, 3 months ago. So, okay, next. This is going to be one of those taxes. I'll do one of these problems for you guys, just as a refresher. So in 2013, Ryan and Jill were married and were filing their taxes jointly. They do not have children yet and will be claiming the standard deduction. Knowing that their adjusted gross income was $80,000, blah, 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 calculate the 2013 federal income tax. Okay, so again, we have this amount in our formulas. It's going to be, that was unit exam formula here. So here we go. We're going to use this tax table. And I'll just jot down their numbers for now. We'll pull that back out in a second. Okay, so this tells me their adjusted gross income. So they told me what I have right now. Adjusted gross income was 80,000. There we go. That's their adjusted gross income. It says that they are going to take the standard deduction, and they don't have any kids, so there's just two people on there. So, sorry, I'm not looking for that. This is what I'm looking for. So I'm going to start off with, I need to first find the taxable income. I'm going to slide this over just a tiny bit because then I think we can maybe see some of this at once. The taxable income is the AGI minus deductions minus exemptions. So I'm looking here at this married filing jointly. So my deduction, there goes, sorry, my thing wasn't working. I'm taking the standard deduction, and for married people, that is $12,200. I'm sorry, 12,200. Then my exemption per person is going to be 3,900 twice, right? We can calculate that right now. You can probably do that in your head, but I'm terrible at math in my head. Wow. I'm also terrible at math on a calculator, actually, it looks like. Oh, sorry, I wonder if my sound's been off. Okay, 7,800. So we'll put that there. That's my exemption. So to find my total, my taxable income, I am going to take my AGI, and it has it right here. Taxable income is AGI minus my deductions and stuff. So I'm going to have my 80,550 minus 12,200 minus 7,800. And again, I'm just going to calculator that. Okay, that gives me 60,550. That is my taxable income. So that's the number I'm going to use with this tax table to figure out how much tax I owe. All right, remember how this tax table works is you take up to 17,850 and you multiply that by 10%. Whoops. 17,000. Looks like a 7, doesn't it? 17,850 times 0.1. Then I add that to whatever's going to be taxed at the 15%. Anything under 72.5 and up to 72.5 is going to be taxed, and well, actually it's in between these two, right? It's going to be taxed at 15%. So what I'm going to do is I'm going to take this number, because this is below 72,500. I'm going to take this number and I'm going to subtract what I already taxed at 10%, 17,850. I'm going to subtract that and multiply it by 15%. Now, if my number had been higher, if my taxable income had been higher than 72,500, I would have another section where I would subtract that number minus, say it was 90,000. I'd say 90,000 minus this, and then tax that at 25%. But luckily, this person, I mean, maybe it's not lucky, but they don't have to pay as many taxes anyway. So I'm going to calculator all of this, and I get 178.50 times 0.1. That gives me 1785. I'm going to write that down. And then I'm going to do this next part. Whoops. I did not mean to. There we go. Okay. Then I'm going to go 6550 minus 17,850 equals times 0.15. So I get 6,405 for my second part. Then I add those together. And I get 8,190, and that is the amount of taxes I'm going to have to pay. Okay. All right, that's the second problem. Move this back over here. Okay, now we're going to skip my third problem. Now I realize yours are not in the same order as mine. Next problem we're going to I just want to talk about this for a second. Which of the following data sets is most likely to be left skewed? Remember that left skewed actually means, so we're looking at a tail on the left and then a lump on the right. That's left skewed. Okay, so what happens, it says, we look at these, the amount of credit card debt of families in Idaho, that's probably fairly standard. It's probably going to be a standard bell curve. The last digits of Social Security numbers, that is also going to be a standard bell curve. The IQs of a class of 36 graders, also standard bell curve. But let's look at this one. The scores on an exam where the mean was 72 and the median was 76. So do you remember that mean is when you add everything together and divide by something, and median is where you have like your numbers. Well, that just does not want to write. Great. My mousey thing's broken. Oh, shoot. Well, oh, my program seems to be struggling. Hold on, let me close this and start it again. I can't pause because it will have to restart. So I've never had that happen. Well, I'll just keep talking about it actually because I can. I don't need to show you. You saw the picture. So what that means is if you have the median and your mean's a lot lower, that means you've had one or two things. Sorry, this is not even closing. It means you've had a couple of numbers. There's my family. It means you've had a couple of numbers that were down at the bottom end that made that long tail. And so if your mean is below your median, then you've got a left skewed thing. You think of it as being to the left of it, and that'll tell you that it's left skewed. Okay, let me open this again. Oh, there it is. And it's writing again. Excellent. Okay, so that's that one. All right, then we'll go to number 7. Oh, can't get there from there. Sometimes I can use that little menu, but sometimes it just doesn't work. I don't know why. Because you can't scroll up on it. It's kind of not the best setup, but okay, here's one. You drive an average of 300 miles per week in a vehicle that only gets 14 miles per gallon overall. Gasoline costs $3.55 per gallon. They want to know how much money you're going to save in a year on a car that gets 23 miles instead. Okay, so what you're going to do is you're going to find out how much it costs you to drive the poor gas mileage car and how much it would cost you to drive the next car. Okay, so we have 300 miles per week. Whoops, I forget that I can't draw on this thing. 300 miles per week, and it gets 14 miles per gallon. So that means I'm going to divide this by 14. So 300 miles per week divided by 14 miles per gallon will tell me how many gallons of gas I have to buy. And then I'm going to multiply that times $3.55. Okay, and then on this other one, it's going to be 300 miles per week divided by 23 miles per gallon times 3.55. On both of these, I'm going to multiply it by 52 because that's going to tell me how many, because that's just for 1 week. So it's going to be 52. All right, so let's look at the calculator. Okay, I get 300 divided by 14, and that gives me my miles, how many gallons I'm going to buy, times 3.55 per gallon. So I'm spending $76 a week. I'm going to multiply that by 52, which gives me $3,900, so almost $4,000 a year on the bad gas mileage car. Okay, so now we're going to find the good gas mileage car. So that'd be 300 divided by 23 miles per gallon times 3.55 per gallon times 52 per year. So it's 2,407. Okay, that's how much it costs me. You know, it's funny. I was having this conversation with some friends. They have a minivan that gets good gas mileage but is falling apart. And they don't have any cash now. They would have cash in maybe 6 months. And they were debating on whether or not it would be smarter to just go get a car that has a good payment. Just they'd have to make payments on it. And then when they get their cash 6 or 8 months from now, they would just pay it off, I guess. But or if they should just keep driving it. And you can see that, and they said, well, it costs so much in gas to drive the Suburban, which is their good car. It gets horrible gas mileage, but really the difference is going to be very similar to this. Gas is not that expensive anymore. So anyway, I'm just going to subtract these two. That'd be $15.48. Okay, so that's how much it's costing them to drive their terrible gas mileage car. Now, that's only a good deal if that's a smart way to go if you're going to spend less than like if you're with your car payments, if you're going to pay more than $1,500 in interest, then you shouldn't get that car. It's not going to be cheaper for you. You'll pay more in interest than you would in gas. So anyway, there's just a life example that we were just talking about just the other day. All right, let's look at the next one. This is your favorite kind. It's the distribution thing. Now I'm going to show you two things you can do. You can do excuse me, some hiccups. You can do the distribution chart like we've done with the 34. And the question always is how can you tell which one to do? If it asks what percentage instead of what percentile, then they probably want you to do the little bell curve. Okay, so I'm going to show you that, but I'm going to also show you that it actually works out the same on this problem either way. Whoops. Okay, I'm going to draw this bigger because last time it's not a very good bell curve. Oh well. Okay, pretend that's an even bell curve. This is the one where you have your median and then you have data points on either side, your standard deviations, right? And then you remember the 68, 95, 99.7 theory here means that this section is 68. That's 34 and 34. Your next section between the next standard deviation is going to be 95 total. Okay, so that means 95 minus 68. It gives you a 7, 9, 8, 27. I divide that by 2 and I get 13.5. Okay, so this little part here is 13.5 and this little part here is 13.5. Now I could work out the 99.7, but I kind of don't need it. So let me show you what I did to speed this along. My mean was 7.3 and my standard deviation is 1.2 pounds. Okay, so I'm going to, I can use my calculator, and they want to know, let me just show you the problem again really fast. So mean of 7.3, standard deviation of 1.2, and they want to know how many babies weigh less than 6.1 pounds. So I'm going down from there. So I'm just going to take my 7.3, I'm going to minus my standard deviation, which is 1.2, and I get 6.1. So that's the number they want. So I really don't need to keep doing all these calculations because I have my line that I need. Okay, so 6.1 is where I want to be. Now, I just need to figure out what's left here. Okay, so this, remember, was 95%. If this is 100%, then everything that is between everything that's left over here and here is 5%, right? I'm not going to mess with this one because I don't need it this time. So everything left between here and there is 5%. I'm going to divide that by 2, so that gives me a 2.5% right here. Now, if you had the next number down, which would be, what was that, 2.1? It would be 4. If you had that number, then you would want to subtract 95 from this and divide that and get those little numbers. But we don't have to. We can just go with a block of 2.5. And then I add that to the 3.5 or 13.5 because I want to know this information right here. And that is 16. Okay. So what's cool about that is that you could actually use these for z-scores. Now I think it works out well because they were asking for a low percent. It might not work out quite as clearly if you go into the upper percents. But anyway, that's what, if they're asking for your reference point is one of the standard deviations away or 2 standard deviations away. If it's one of the exact standard deviations, then you're going to want to use your little chart. Whoops. Okay. Oh, I was just going to show you this one because I did it wrong. Because I thought that, well, I'll just show you. It's one that had multiple answers. This one, which set below does the number, to which sets below does the number negative 3.4 belong? I just stopped at real numbers and I clicked on real numbers and then I checked it and it was wrong. And so then I was like, oh, they want me to mark more than one. So it's real and rational. So you can figure out that part. Just remember that that is a possibility that they will have you select more than one answer because that kind of threw me off a little bit. And we're skipping that. And after I get to 16, then I will be able to access those problems. Okay, here's 13. Suppose your English teacher randomly selects 20% of the papers turned in by students for each assignment and runs them through a program that checks for plagiarism. If there are 5 papers assigned throughout the semester, what is the probability that at least one of your papers will be checked for plagiarism? See how they highlighted that at least? That's because there's a formula for that. Do you remember these? Here's our at least trial. At least one event is 1 minus the probability that it's not your paper times the number of times that's going to happen. Okay, so we're going to start with that. Our formula is 1 minus naught, and that's raised to the n. Okay, so this one said that 20%, she randomly selects 20% of the papers turned in. That means there's an 80% chance that it's not mine. Okay, so it's 1 minus 0.80, or 0.8 I can just write. And n is how many times I'm going to come up. How many times is that going to be a risk? And they are doing 5 papers. So there are 5 chances, so that's going to be right there. My n is going to be 5. And then I just put this on the calculator. And I go 1 minus, we'll do it this way. Sometimes calculators don't like that. We'll do 0.8, and then x to the y 5. Okay, that gives me that number. I'm going to make that negative, right? And I'm going to add it to 1. And I get 67%. Okay, so just remember your formula sheets. Like if you're not sure what you're supposed to do, look at your formula sheets and see if you can find something. All right. Aha, I'm finally to a problem where I can use my little question menu. Question 17 on my test. Okay, suppose you pay $33.89 for a new pair of shoes, including tax. Given that sales tax in Idaho is 6%, what was the pre-tax price of the shoes? So on these, I always just think through it as if I were in this situation myself. Okay, so I paid $33.89 for a pair of shoes. Okay, I know that that is the price of the shoes plus tax, right? So they want to know what the price of the shoes was. I've got to figure out what the tax is. The tax is going to be, it told me the tax rate, 0.06 times the price of the shoes, so 0.06p, right? So I'm going to have the price of the shoes plus 0.06 times the price of the shoes. Okay, you can write that if you remember p times 1 plus, 0.06, or p times 1.06. All those is equal to 33.89. Okay. So now I have to get p by itself, and I would just divide through by 1.06. And my answer is going to be 31.97. Okay, after I do that division. Now, let me show you something. If you had come back up here to this formula, which is kind of hard to read because I wrote it sloppy. Let me try that one, 0.06p. P plus 0.06p. If you didn't know how to get to this, you could add p plus, so this is like 1p plus 1.06p. So that's gonna give me 1.06p if I write it out like that. Okay, so then again, I would solve for p, I would divide by 1.06. You end up doing the same thing, but if whichever one of these makes sense to you, this p plus 0.06p or p times 1 plus 0.06, either one's fine. Okay, this is a probability thing. A 5K race has 35 participants and prizes will be given to the first 3 finishers. Okay, how many different ways could the prizes be awarded? So I'm going to pull out my sheet. I'll do this up here because I think we can. All right. So I am trying to find the probability based on, excuse me, I need to guess. I need to determine if the repetition is allowed, and then also if order matters. So in this case, Repetition is not allowed. I cannot win first and second place. Only one person can be in each place, right? So repetition is not allowed. So it's going to be either this formula or this formula. And then I'm going to come over and I'm going to say, I'm sorry, it's going to be, yeah. And then I'm going to come over and I'm going to say, does order matter? And order does matter. It matters if you get first place or second place or third place. So we are dealing with a permutation, which the formula for this is right here. So I'm just going to write that formula down. So my permutation formula is n factorial over n minus r factorial. Now in this case, we had 35 people that were running the race. And it's going to equal n, right? And then r is going to be there 3 places. Okay, there's three places those 35 people could go into. So that's my r. So then I just work it out like this. I go 35 exclamation point over n minus r. So sorry, 35 minus 3. Wow, that was very loud. My son's computer just turned off and back on. 35 exclamation point over 32 exclamation point. And you just do that on your calculator. Whoa. Uh-oh. I feel like something bad happened. Well, hopefully I'm still connected. All right. Okay. Here's this 35 exclamation point divided by 32 exclamation point. And I get 39,270. Okay. So it's kind of, that's a lot of different ways that can come up, right? Whoops, that wasn't what I wanted. I wanted this one. Yep, so that's your answer right there, 39,270. So again, if you're not sure, read through these, and they've got this little chart that's fabulous. These give you a very good explanation, so use your formula sheets. All right, let's go on to nope, sorry. I'm sure like, can she grab the right thing? And the answer is no, I cannot grab the right thing. Good question. Oh, oops, 21. Okay, you want to retire with $500,000. You have 45 years to achieve it. What lump sum could you invest now to reach your goal? Now, there are formulas on here about interest and this kind of stuff. No one wants to do this formula. No one. Right? Or that one. They're terrible. So, lucky for us, we can use our financial calculator. Right? So, they want to know what lump sum I could invest now. So I want to find my present value based on the future value I want. So I'm going to already put these numbers in yesterday's because I always work through my tests. So I do put 500,000 in there. And it's telling me that it's 8%, so that goes there. It's compounded monthly, so I get 12 there. I'm not making regular payments into it. I just want a lump sum. And I have 45 years to get it. So they're telling me that if I invest $13,000, $13,826, then I'll have my lump sum of $500,000 in 45 years. So that's right there. Okay, so just remember that you have those calculators. I think I'll show you one or two more of those, but they're pretty sweet. Saves you tons of time. All right. Okay, this one, suppose you invest $83,500 in a house and then sell it 5 years later for $104,900. Find your total return and annual return on your investment. Okay, so I have, whoops, sorry. Whoa. Okay. $83,500 that I bought a house with, right? And then later I sold it 5 years later. I sold it for $104,900. It's a pretty good profit. They wanted to find out what the total return is and what the annual return is. And they want your answer in parentheses, okay? They don't, I'm sorry, in percentages. They don't want just how much money you make. They want to know what your, a return is a little different than your profit, right? So your profit would be different. Your return is relative to what you invested. So let's look at that. There's actually a formula sheet for this. So your annual return is right here and your total return is right here. Okay, so A is the amount that you have now. P is the principal that you invested. So I'm going to write these formulas down. So your total return is A minus P. So your amount that you have now minus the principal you invested over P. Okay. In this case, that would be 104,900. Wow. Too many zeros. 104,900. That would be really a good investment, right? 104,900 minus 83,500 divided by my principal, 83,500. Okay, so and I'll do the calculator on this in just a second. Your annual return, it seems like you could just take that answer and divide it by 5, but you can't because they want it, well, because it's not accurate. It's kind of close, but it's not accurate. So this formula, sorry, is the compounded annual growth rate annual return right there. So A over P to the 1 over Y, right? So in this case, A is, again, 104,900 divided by my P, which is 83,500. That is raised to the 1 over 5 because it's 5 years. Okay, now let's pull out our calculator and we'll finish this off. Okay, this first one, I'm going to go 104,900 minus 83,500. So that tells me my profit, how much I made. They want to know what percent, how does that relate to what I invested. So I'm going to take that and divide it by 83,500. So that is 25.6%. Okay, you could actually, in this case, get the answer from here. Where did that go? Oh, here it is. Okay. See, like I can see this is the only one, this is 25.6. This one's 25.6, but it's negative, which would have meant that I'd lost money. But let me show you how to calculate that last rate just in case there's one that comes up like this. So this one I have my A over P. So, oops, that's not my calculator. Okay, so my amount is 104,900, and that's divided by 83,500. So I get this number right here. Now I need to raise that to the 1 over 5. I'm going to do it the cheater way. If I have a fraction up there, it's actually like a square root. If I have a fraction in my should be an x. If I have a fraction in my exponent, then it's my bottom number is the square root. So I'm going to take that number and I'm going to go the square root, or the root of the 5th root of that. And I get, oops, I did something wrong. Oh, that's -1, sorry. This whole thing has a -1. This has -1. Okay, so then my answer is going to be 4.6. Oh, it deleted it. But anyway, that's the correct answer. So just remember to use this formula. Don't forget your -1. And that's that one. Okay, next. All right, the Burtons would like to pour cement for a new patio. The patio measures 15 by 25 feet, and they would like the cement to be 4 inches thick. How many cubic yards of cement will they need? There are a few things that are a problem on this problem. Let me show you what they are, the potential stumbling blocks on this problem, which just reminded me, we were reading scriptures as a family the other day, and my daughter was reading, and it was talking about stumbling blocks, and she skipped, it was early in the morning, and she skipped a line. And so she said something bling blocks. And we're like, bling blocks? What are bling blocks? Anyway, the word had been hyphenated, and anyway, it's pretty funny. Okay, so patio measures 15 by 25 feet. And then they want it to be 4 inches thick. Here's your first place that can screw you up, is that it's 4 inches, and then this is feet. Okay, so we need to convert either these feet to inches or these inches to feet. I chose, because we're then going to cubic yards, I chose to do this feet to inches. So how I do that is go 4 divided by 12, tells me how many feet that is. So it's, oh no, my thing's going wonky again. There it goes. 30.33, okay? That's my feet to inches. Oh, come on. So if I want to find out the total volume of this, I'm going to go, 15 times 25 times 0.33333. Okay, let's get out my calculator. And I can even do this first if I need to. 4 divided by 12 equals 0.333 times 15 times 25. So I get 125. So this is 125. And that is going to be cubic feet. But they want to know what it is in cubic yards. So feet to yards, there's 3 feet, right, in 1 yard. So I'm going to divide this by something. But guess what? It's not going to be 3. And it's not going to be 9. It's actually going to be 27. It's going to be 3 times 3 times 3, because there are 3 dimensions to this thing that I'm making. So it's 3 times 3. So that's 125, divided by 27. And I get 4.63. So that is how many cubic yards of cement I would need. It's 4.63. So just remember that when you are working with like cubic yards, if it was square yards, it would have been 3 times 3. If it's cubic yards, I have to have that third dimension in there. So just remember that. Okay, getting closer. All right, I'm going to do another conversion problem. That was like a very simple conversion problem. I'm going to do one of the harder ones because those, well, they're harder, right? So I never liked conversion problems, but I did finally figure out how to do them. All right, so suppose you're visiting a friend in Canada and you find a liter of milk in the grocery store priced at $1.90 Canadian dollars. Given that there are 3.79 liters in a gallon, excuse me, I did not get a lot of sleep last night. So you can't see me yawn, but you can hear me yawn. But I've been, Christmas time is busy, and I would just wake up at like 5 o'clock after going to bed at midnight and thinking, oh, I have so much to do. Okay. Anyway, there are 3.79 liters in a gallon, and 1 Canadian dollar is equal to 89 cents. Okay, what is the price of milk in dollars per gallon? So what I like to do when I do these is the first thing I do, I'll bump this down here again so you can still see it. I should have done that earlier. So I write down what I have. I have milk priced at $1.90 Canadian per liter, right? I don't have a gallon, I have a liter. Okay, so I have I have Canadian dollars per gallon per liter. Sorry, that's what I have. What I want to end with is US dollars per gallon. Okay? So I always do that. I write down what I start with and I write down what I end with, and then I use the information I have to fill in the rest. So I'm going to start with, it tells me first that there are 3.79 liters in a gallon. All right, I want gallon on the bottom. Right now I have liter on the bottom. So I'm going to multiply this by something that has gallon on the bottom and it has liter on the top. Okay, it told me that there are 3.79 liters. 3.79 liters in 1 gallon. 3.7 liters per gallon. Does that make sense? So you've got, I put that on the top and this on the bottom because these units are going to cancel out. Okay, and then I have gallons where I want it, which is on the bottom. Right? So then I go from my Canadian dollars to American dollars. This time I want my American dollars on the top. Look how convenient that is, because I can put my Canadian dollars on the bottom and they'll cross each other out. So it tells me that 1 Canadian dollar, so the one's going to go down here, 1 Canadian dollar is equal to about 0.89 US dollars. Okay, and then I have my dollars per gallon, and so I just do the math, which in this case is just multiplying straight across. 1.9, 3.79, 0.89. Okay, I'm not going to calculate it out for you, but anyway, that's how it works. The next one is a Venn diagram. A little reminder on this one. I'm almost done. Ish. It asks how many cookies do not have walnuts. My initial thing was to look at here and go 15, except that you have these 7 cookies over here. So watch out for those that have neither chocolate chips nor walnuts, right? I'm also not going to calculate this one out, but just remember this one, the population in your hometown is grows 4.5% on average. What is an approximate doubling time for the population? Okay, doubling time, where did that one go? It's on the very first thing. Oh, there it is, rule of 70, approximate doubling time, where P represents the rate. So P represents your percent. So it's just 70 divided by 4.5, right? So that's super easy. Okay, a couple more. There we go. You flip a coin 3 times. What is the probability of getting exactly 1 head and 2 tails? When they are looking, so my initial thing was I was like, well, the probability of the first one is 1/2. You know, like probability of the second one is 1/2. Probably the third one is 1/2. Sort of. Okay, that gives us part of our answer. But because they want something very specific, this is one of those. I'm moving these the wrong way. This is one of those where you're going to have to write out the heads and the tails. Okay, those were kind of a pain if you'll remember, but luckily there's only 3 on this one. Okay, so the probability of getting exactly 1 head and 2 tails. If I flip a coin 3 times, I have a total of two, because there's two choices for my first outcome, two choices for my second outcome, and two choices for my third outcome, right? So I multiply those together and I have the possibility of 8 different scenarios for coin flipping, okay? So I need one head and two tails. So HTT, heads, tails, tails, is one option. I could also invert that and go tails, heads. Whoops, I can't. Sorry, because that changes my number of heads. So I can also just think of the different ways you can match this up. Tails, heads, tails, or tails, heads, heads. Okay, those are my only ways I can get one head and two tails. So that means I have a 3 out of 8 total chances. So 1, 2, 3 out of 8 total chances of getting that. Okay, so just remember that that's how those work. Okay, I'm going to just show you really quick. All right, suppose a polling company announced that 63% of Americans are dissatisfied with the performance of Congress. If the sample size was this many people, calculate the 95% confidence interval. 95% confidence interval, there's not something that says that on your formula sheet. So you need to know that when they have a 95%, when they're talking about the confidence interval, they're talking about the margin of error. How big can my error be and have me still feel fairly confident that it's accurate? So I'm just going to use this formula, which is 1 over the square root of n. Okay, so that my n was 1034, right? 1 over the square root of so I go 1034 square root, flip it over, and I get 0.031. Then I'm going to take that 0.031, which is 3.11%, and I'm going to add that to, see how here how it said 63%? I'm going to add that to that. So I'm going to have 66.1% for one end because I take my 33, no, sorry, 63%. It was 63%. Okay, so I add that. That gives me one end of my interval, and then I subtract that, which gives me 59.9 on this end. That's my confidence interval. Okay, the last thing we're going to do all right, this one, the couple has 4 children. I'm not going to do this one, but what is the probability that they have exactly 2 boys and 2 girls? This is just the same as the coin toss, except in this case we're dealing with 4. So I have 2 choices on my first kid. Wow, here we go. 2 choices on my second kid, third, fourth. So I have 16 choices this time total. And then I'm going to do this boy, boy, girl, girl, boy, girl, boy, girl, girl, boy, girl. I'm going to keep doing that until I can't think of any more. Okay, so that's how that one works. And then the last thing is something from kind of a little while ago. Oh, it's not. This one is expected value. So it was just in Unit 3. I guess that was a little while ago. But a high school club is selling raffle tickets for a fundraiser. Tickets cost $2. 1,000 tickets will be sold. If the prizes are a 250 iPad and five $25 gift cards, what is the expected value of the ticket someone buys? Okay, so when it says expected value, we're going to come here, look at this. I do my event value, the value of my first event times the probability of the first event plus the second event plus the third event, right? So the value of my first event is, I'm going to go back to how much it costs, okay? I'm going to look at the prizes. Value of getting a prize, if you get the prize, it's 25 or 250 divided by 1,000 is my probability, right? A better way to write that, sorry, so that it looks like the formula is I have a 1 in 1,000 chance of getting something that costs 250. Okay, so essentially it's 250 divided by 1,000. Okay, same thing here for the 5 iTunes gift cards. So that's, sorry, I have a 1 out of 1,000 chance. Actually, I have a 5 out of 1,000 chance because they're going to draw 5 of those. 5 out of 1,000 chance times 25 because they're worth $25, okay? So that's, well, it'd be it'd be 125. So 5 times 25 is 125 divided by 1,000. I'm going to add this. Well, let me calculate the numbers first. I'm going to go 250 divided by 1,000 and I get 0.25. That means that one's worth 25 cents, right? And then I'm going to get 125 divided by 1,000, and I'm going to get 0.125. I'm going to add those together. I'm going to get 25 cents plus 12.5 cents, right? And then I'm going to add in, well, it's really subtracting because this would be money that I would be earning, but I spent $2 to get that. So I'm going to subtract the $2, and when I add them all together, I get 0.25 plus 0.125 equals minus 2. I have a negative value, negative 1.63. That's how much, what kind of gamble, what kind of risk I'm taking, or the expected value that's going to cost me money. Okay, that's it. So here's hoping that this score is going to be great and you'll be able to drop one of your other tests because of it. Let me know if you have any questions.